Good afternoon, ladies and gentlemen. I'm going to pick up some of the points that Ronald Pearce just described, but start with current status, just to remind ourselves where we're at. We had this ecodesign regulation 327 for fans. It was published in 2011. It came into force in 2013, and in 2014, the Commission started to review that regulation. In 2015, they had a consultation forum and published a proposed draft. There's a lot of discussion since 2015 and now, in 7 years, there's been a lot of noise. Now we're starting to see some progress, and we see what is coming. Ronald just showed us on the screen there. In parallel, there's some standardization work happened, which I'll talk about. And there's been lobbying from stakeholders for an energy efficiency index for our products. And as we saw, Ronald has now restarted that process of review, and we're moving forward. The standardization for the current regulation is prompted by a mandate, and SEN TC156 Working Group 17 produced this draft standard to answer some of the open issues we had. What is a fan? What's the boundary? Even what is a backward curve mixed flow centrifugal fans? There wasn't clear definition, so we put that into the standard. It's interesting that that's now been adopted into the international ISO standards. It's also now been adopted into the current the proposed draft regulation. But the last 2 or 3 years, well, 4 or 5 years, we've had a lot of pressure from other stakeholders to have a new metric to define the efficiency of fans. It started with the consultant back in 2015 being critical that very little had been introduced by the industry. We see pressure from other standardization committees suggesting through the IEC 61800 series that an energy efficiency index is appropriate for fans. We see green NGOs saying the same thing. What is it? An energy efficiency index is taking 4 operating points across the range of the product. It exists for circulators. This has come out of an EN standard for circulators. The principle is you measure the consumption of those 4 points, and you take a weighted average over a year's operation. This has been pushed by green NGOs as well. But we don't think it's appropriate. The fan industry and EVIA doesn't think it's appropriate for fans because the fan has a very wide operating characteristic. Fans are used in many applications that we see as we walk around the exhibition today. And those 4 operating points is not representative of the many different operating characteristics that can occur. One fan, one part number could be used in many different applications, and it could be used at fixed speed, or it could be used at variable speed, constant volume, constant pressure, variable volume and pressure. So we argued that's not appropriate. We put these pressure points, we put these arguments together in a problem statement where we looked at the challenges proposed to us by the Commission, what the stakeholders were saying, what does an EEI mean to us. We came out with a proposal that it's not suitable, but what we said was we should do the same as the motor regulation. The motor regulation has recently changed about a year ago, and there's a requirement to provide data across the whole operating range. And then users of motors can determine what the losses are at any operating point. It should be the same with the fan. In reality, that's what happens today. Many fan manufacturers provide that information, provide selection programs. The thing is, it's not standardized. So EVIA initiated this idea of using a standardization request. This is the new vehicle that the Commission uses to communicate to standards bodies what we need for European standardizations. It was previously mandates, it's now a standardization request. A big difference is a legal document. It defines very clearly what the Commission wants of a standards body to do. So we've taken the liberty of putting one together and proposing to Ronald Pearce, we think this is what you should be doing. So we said, don't use it in EEI, use something similar to the fan industry. We saw that there was some limitations in the current standards. We don't define partial load operation. What does it mean? And there's also some elements missing for circulating fans. So we put this together. It's very interesting to see that Ronald's already adopted it. He's put it into his draft standard. The proposal is fairly straightforward. We have to provide a number of operating points and operating curves. Ronald has taken up the suggestion of 3, inherent speed, minimum speed, and 1 between the two. And with sufficient, what is sufficient, and this is where standardization comes in, what is the sufficient number of operating points to define that curve. And then anywhere in that operating range, you can interpolate and define what the losses are at any point. And that now gives that data to users and selectors. What's missing in standardization is an agreed way of interpolating. Us manufacturers, we do it already. It's in selection programs. We all do it slightly different. If it's in a standard, then everybody does it the same way. If you don't have to do it as a manufacturer, it's users can interpolate in the same way, and therefore you get a standardization of the results. So just come back one. This is what we've been doing over the last 2 or 3 years, and we now see Ronald's actually picking up those suggestions, and he's put it into the draft regulation. So he's picked up some of the definitions we've suggested. He's picked up this idea of minimum of 3 performance curves. Some outstanding points, though, is calculation versus direct measurement. It's an open point. It's an open question. Currently, 327, you can determine the performance of your fan by doing a direct measurement, or you can calculate it. You'll see in the new draft, you can only measure it. Probably a retrospect. I mean, we pushed it as an industry. We didn't want the measurement, a calculation approach, but it's not right for some fan manufacturers. Some fan manufacturers still need that ability to calculate and not measure. The reason why we as an industry pushed against the calculation is because there's this compensation factor, CM, that the consultant at the time recognized that if you took all the components in the fan, the impeller, the motor, the belts and pulleys, you took the losses or took the efficiency of those, it's not always matched together, and therefore you take them together and then the CM is 0.9. You then multiply your answer by 0.9, you bring down your stated efficiency by 10%. And people didn't like that, so we lobbied to get away from a direct measure, a calculation approach, and just have a measured approach. For those of us that measure our fans, that's fine, but for those that use calculation, it's an issue. The thing is, though, is calculation always appropriate? There's a number of components in that fan, a minimum, impeller, stator, and motor. There can be others. There can be mechanical drive. There can be belts and pulleys. So in standardization, you have 2 approaches to measure your fan. You can do a direct measurement, measure the air power out, measure the electrical power in, and then from that you can define your efficiency. Or you could take the components and you can take the efficiency of each component and multiply them together. The issue is the first component, the impeller, is a measured component. You can only measure the air power out and the air power in and the efficiency. The next component, your belts and pulleys, are factors, assumed. There's no standardization really that says this is what the loss of your belt and pulley is. It doesn't take into consideration 1, 2, 3, or 4 belts or whatever, or how the tension on the belts. Then you've got bearing losses. Again, the bearing losses are standard. And then you have the motor's not so bad now because the motor is better because motor manufacturers have to provide more data at any point within the operating characteristic, and you can interpolate between those, except not above 50, 60 hertz. So if you're driving your motor, your impeller much higher speeds, then the losses of that in the field weakening range is not standardized yet. I know IEC are working on it. So that's the difference between the two. The other issue is, does it account for all the losses? So if you take something simple like a fan in a short case, you can measure that device, electrical power in, air out, Or you can measure just the impeller only. And when you measure just the impeller only, have you considered the losses that that motor may impose from an aerodynamic point of view? It's in the airstream. And in ISO TR 16219, this looks at the inlet and outlet effects on a fan. And it states in there, I forget which section it is now, that gives an example of a pillar bearing in front of the fan, and what that adds to a loss because of an aerodynamic loss. So if you do a calculation, you get that pink curve. If you now measure, because now you've now taken into the effects of the aerodynamic losses, your efficiency is actually slightly less. So what we're saying is, yes, we need some sort of calculation approach, but the calculation approach has got to be at the right time, and you can't calculate aerodynamic losses, so you've got to have somehow take that into the consideration so that when it comes to legislation, legislators don't just take a simple approach, measure, calculate. They've got to be taking an approach of, well, you can calculate, but only when it's appropriate. Define appropriate. Okay, other things that are missing. Currently, the current regulation regulates jet fans, but they all fail because the limits are wrong. That's going to be addressed. Ronald didn't explain in detail, but it's addressed in the new revision. From a extended product part load point of view, what should we do? Well, we've suggested a few things. I won't go through every point there, but it's fairly straightforward, and we don't think it needs standardization. Circulating fans is an interesting one because, again, they're within scope of the current regulation, they're within scope of the revised draft, but there is no methodology and the limits are not appropriate. So they still fail in that you can't make them, you can't stop placing them on the market because you can't actually measure them. But there's one of those quirky situations where, strictly speaking, they're inside the scope and they fail because you can't measure them. But the Commission acknowledges that's the situation. So we as an industry need to do something. There's standards for fans below 125 watts, but they're not appropriate. We don't think we have to do something above 125. There's standards in America that probably are appropriate, and we need to think about how do we bring that into Europe. So where am I? Sorry, gone too far. So we think. To give an overview, we've produced some standards for the current regulation. We need to move those standards forward, bring in some new definitions, bring in the requirement for part load operation. We have to bring some standardization for circulating fans, not necessarily for this regulation, but for the next time it's reviewed. So that gives a quick overview of standards in the world of fans.